No better way to spend your Friday. Last period of the day, too. When you are adding or subtracting rational functions, your first focus is the denominators. You have to have a common denominator in order to add or subtract fractions. And this is why people actually find the multiplication division problems of these a lot easier. You don't have to do this with the multiplication division, and I'm going to repeat that when we get there. So adding, subtracting, factor the denominators into linear factors. And so two numbers that multiply to make -8 and add to make -2. And then two numbers that multiply to make 32, but when you add them, you get -12. Anyone have those yet? Very good. All right. Well, there are going to be a lot of fine details where I know people make mistakes that I'm going to comment on as we go along. One of them is actually probably the biggest one is, when are you allowed to cancel? You can only cancel when you have multiplication, and you can only cancel things that are multiplying to everything else in the numerator, and also things that are multiplying by everything else in the denominator. It has to be multiplication only. If you see something like x squared plus x plus 2, and down here you see x plus 2, you can't cancel the x plus 2's because of this addition. This addition causes all of this to stick together like glue unless you are able to factor it. Then the individual factors are like glue. I also see people making the mistake of doing and I'm just throwing out some random things. Say x squared plus 5x minus 1, x squared plus 6x plus 2. You cannot cancel these x squareds. They are adding to other things in their numerator and their denominator. And that is a key problem that I find students having, including when they get to calculus, they're still having problems with these. So if you really work on this hard, you can become much better at this. All right, now here we go. Denominator number 1 in blue. Sorry to the colorblind folks in the room. Or sorry, in the meet. We're not in a room. Okay, denominator in blue, the first one. It looks over to the other denominator and asks, what does that denominator have that I don't have? And you need to then multiply its numerator and denominator by what it doesn't have. So I'm going to multiply that x plus 3 by x minus 8, and the denominator being multiplied by x minus 8. And realize that, yes, the x minus 8s could cancel out. We brought them in so that we can add or subtract the numerators. So know that when you're in this process, you are, shall we say, simplifying the fractions and bringing in things that you would normally be canceling to simplify. But we have to simplify it in order to get the same denominators. Now, the denominator on the right in green looks over at the blue denominator and asks, what does that denominator have that I don't have? and that would be an x plus 2. So I multiply its numerator and its denominator by x plus 2. Got to make sure I have a parentheses around original numerators, because that giant fraction bar, this giant fraction bar, is a parentheses as well as a fraction bar. There's an understood parentheses around the numerator and the denominator. Okay. Now, I have a common denominator. And what I'm going to do is, before I subtract them, I'm going to multiply things together. So I have x plus 3 times x minus 8. Maybe I need to go to the side and make a box. If you can do the multiplication in your head, that's fine. But I need you to know something very important. When I see your work, when you turn your homework in, I need to see some work done. You don't have to do as much work as I'm showing, but you don't get to an answer by guessing. There is algebra work that has to be shown, and some of you aren't showing work in your homework, and it makes me think you're not actually doing the work. All right, multiplying x plus 3 and x minus 8. Oh, and I've been taking points off if you don't have the work shown. Good. Yep, you got it. And then I'm going to write that down with adding the like terms together. Negative 8x plus 3x gives me negative 5x. And if you want, I can just go big giant extension minus, and then focus on the other numerator multiplication. So focusing on the other numerator multiplication, I'll do another box. And I'm multiplying x minus 5 and x plus 2. And so I end up getting x squared, adding like terms, negative 3x, and then minus 10. But be very careful with these darn subtractions. When I have a subtraction in a parentheses, I always go add the opposites, and it changes dramatically whether I make mistakes or not. Now you're adding like terms. So you have x squared plus negative x squared. Ha 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 ha. Bye bye x squared. Then we have negative 5x plus positive 3x, giving us negative 2x. Then we have negative 24 plus 10. And that would be my simplified numerator. Now, you don't want to quite call it quits yet. You want to check, is it possible to factor this numerator and have that cancel with something in the denominator? Now, I don't expect you to factor the numerator unless you want to. You can leave this as your final answer. What you have to be careful of is sometimes the numerator can be factored and end up canceling with a denominator. And so let me see. Did I make any mistakes in there? Oh, there we go. Yeah. Did anyone notice I did negative 24 plus 10 and negative 24 plus 10 is 14. Huh, there we go. So if you want, you can factor a negative 2 out, but I am not going to expect you to do that unless there is a cancellation to be had further down. Okay. So how are you doing? Can I mute? It is distract. Oh, Jason. Yes, you can mute if you want. Okay, then if we have time, I will come back to another one of these problems. Let's see. Let's do number 19 together. Multiplication and division with rational expressions are so much nicer to deal with than addition, subtraction. You do not have to worry about a common denominator. It's just a big giant game of factor kill, ha ha ha. Now, when you see division, you're going to change it to multiply by the reciprocal. Now, you're also factoring as much as you can. So if I factor 3 times x minus 9, I can take out a common multiple of 3 and then divide 3x by 3, divide 9 by 3, and then I have factored that piece. The denominator of 2x plus 8 that was in the numerator, I can factor a 2 out, 2x divided by 2, and 8 divided by 2. Then I'm now focused on this numerator, and I am factoring that quadratic. So 2 numbers that multiply to make 16, and when I add them, I get 8. And what do you see? I'm hoping you're seeing that it's x plus 4, which you can write as x plus 4 squared, or you can write it as 2 separate x plus 4s multiplying, either way. Now I'm looking at the denominator I just highlighted and factoring that. How does that denominator factor? You got it. And possibly, but I lost track of what you were saying, and it's it's because I'm like super focused on this, and I don't have a great ability to juggle, if that makes sense. I was trying to listen to you, but let's see if this is what you got. So I can cancel anything in a numerator with anything in a denominator when I'm multiplying. Everything's multiply. Then I get that cancellation, and I think that is what you said. I have left over a 3 and a parentheses x plus 4, and a 2 and a parentheses x minus 3. That is what you said, right? That's what I thought. Good job. Now, that's reminding you of how to deal with multiplication division. It's the fun one where you get to go die to all the factors, but they must be factors. Okay, now I'm going to do one of the solving problems. And I'll do number 25 with you. So these problems, if they have addition in them, they're as tricky as it is with adding and subtracting and trying to get a common denominator. Understand, though, that you have options when an equation is involved that you don't have without it. The option is when you have an equal sign, you can multiply both sides by the same thing and get out of having a fraction. But when you are doing the addition, as we looked at just a moment ago, you have to get a common denominator and you're stuck dealing with it in fraction form. Now, you want to see if there are common factors. So anything that is more than a linear, higher than degree 1, check to see if you can factor it. So let me do this denominator. Can you see that x squared will divide both terms? And if I divide both terms by x squared, I will have x cubed divided by x squared to give me x, and 5x squared divided by x squared to give me 5. The x plus 5 denominator, there's no factoring to do there. The x squared denominator, it's as simple as it's going to get. But you notice that there are some commonalities. Now, your choice is, do you want to multiply by the entire least common denominator? Or do you want to slowly chip away at it and multiply by a factor at a time? That's up to you. For some people, they do a better job if they just go one factor at a time. I'm going to show you taking the entire least common denominator and multiplying both sides by that least common denominator. And so if you look at it, this denominator has x squared and x plus 5. This denominator has the x plus 5 of that denominator, but not the x squared. This one has the x squared of that first denominator, but not the x plus 5. That makes this pairing the least common denominator, and I can just multiply by that whole thing at once. So I'm going to go multiply by x squared times x plus 5. On the left side of the equation, we don't have addition or subtraction like we have right where I'm highlighting. So I don't have to worry about trying to use the distributive property of multiplication over addition. That's needed on the right side. But if you take a look back, can you see the difference between the addition of two separate fractions versus just a single big fraction? When you are multiplying, you can look at it as multiplying by that fraction divided by 1, if that helps. And then we multiply across the top, multiply across the bottom. I save myself time if I realize that these cancel and I just am left with 5. But be much more cautious where you have to do the distributive property. I need to take the 4 over x plus 5, and I need to multiply to it the x squared and the x plus 5. Then my plus sign, and then the 1 over x squared needs to also be multiplied. Now, if you see the cancellations that go on while you're doing it, you can go for it. I'm going to try to show this at a slow but not too slow rate. And that just bothered me because it didn't look well. Anyway, all right, let's see. Fraction, that one. The x plus 5 in the denominator and the x plus 5 in the numerator. Notice it's multiplying. I can put parentheses around them and see that they are multiplying. They cancel. The last fraction, x squared, cancels. And notice it is multiplying in its numerator and denominator. Now I reach the step that I've been waiting for. On the left, I have a 5. On the right, the only thing left after the big kill is 4x squared. Then I have that same plus sign, and all that's left of the last fraction is an x plus 5. I don't need the parentheses anymore. And now it's polynomial. When you reach the point of it, you have the polynomial, and it's no longer having denominators. Then your goal is set one side equal to 0, factor, solve for each factor equaling 0. So I'm going to subtract 5 from both sides and go, yay! Plus 5 minus 5, bye-bye. Oh, that makes me miss, what's it called at Disneyland? Star, help me out. Because I want to say Star Wars, Star Trek. No, Star... Do you know what I'm talking about? The simulator where it's Star Wars. They play a video, you move around and go, in it. Never mind. Tours, Star Tours. I'm just wondering when or if I will ever see Disneyland again. Oh, yay. Okay, anyway. I can factor a common x, and then that leaves me with 4x plus 1. Each factor is this one a no solution? Not quite. Not quite. You have 0 equals x, and you also have 0 equals 4x plus 1. So set each factor equal to 0 and make sure that they are not extraneous. And that extraneous check is just look at the original denominators. Anything that makes an original denominator 0, and by original denominator, I am referring to these 3. Anything that makes any of them equal to 0 is not able to be a solution because it's a divided by 0 problem. So that means x equals 0 is not a solution. But what do I have on the other equation? Subtract 1, and then divide by 4. Does -1/4 make any denominators from the original equal to 0? So we did get an answer. Yay! So at this point, I've gone through one of each of these main types of algebra situations. I can go back and do a second problem of each of the algebra situations. And I think that's probably going to be the best thing for you. So let's see. Which one should I do? Which one should I do? Yeah. Oh, yeah. I need to start over here. All right. So adding, subtracting, it's the thing that requires you to do that common denominator. So you want to really get set in your head that in order to add or subtract fractions, you have to have the same denominator. You want to factor any quadratic denominators. So how does x squared plus 5x minus 24 factor? Did some of you get that? Positive 8, negative 3? So now, to get the common denominator, each denominator needs to look at each other and ask, what do they have that I don't have? The first denominator says, you don't have anything I don't have. But the second denominator looks over and goes, oh, they've got an x plus 8 and I don't have one of those. So multiply its numerator and denominator by x plus 8. If you multiply the numerator and denominator by the same exact expression, you're not changing the algebra of that expression. So that means that I have 12 plus, and then I need to distribute the multiplication of 3 over the x plus 8. So 3 times x plus 3 times 8 over the common denominator. If there are like terms to add together, you need to do that. And you also have to double check if the numerator is factored, can it cancel with a denominator? So can you guys think of what the numerator would look like if it was factored? You can factor a 3 out, but that's going to leave you with an x plus 12. Is that going to cancel with anybody? Nope. That means that I will accept as a final answer this version or this version, whichever you like. They're both correct. So now that we've done 2 problems with addition, subtraction, I'm hoping that you're feeling more comfortable, especially when you've been off of doing these problems for a few days and had time to rest and let it kind of soak in a bit. All right, let's do number 18. It's multiplication, so I don't have to worry about the whole multiply by a reciprocal that I did with 19. I just need to factor and factor and factor and factor. So I'm going to highlight who I'm focusing on. Two numbers that multiply to make -10, add to make -3. And now I'm going to highlight who I'm now factoring. As long as there's just an understood 1 in front of the x squared, then you can just put a couple of x's down and think two numbers that multiply to make +3, add to make +4, and you're factored. Times, the factoring never ends. Ha, 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 ha. All right, I just highlighted who I'm looking at factoring now. Again, there's just an understood 1 in front of the x squared. So I need two numbers that multiply to make -3, and when I add them, I get +2. And now I'm highlighting the polynomial I'm factoring now. Again, it has just a 1 in front of the x squared, or an understood 1. So two numbers that multiply to make -2, add to make +1. And now multiplication with fractions just multiplies across the top and multiplies across the bottom. So basically I can just turn that into one big fraction. And let's look at who's out of here. I see x plus 3s. I see x minus 1s. Ooh, there's more! Yay! We got to get rid of a lot of stuff there. Sometimes there's a lot to get rid of, sometimes there isn't. I'm left with x minus 5 for the numerator and x plus 1 for the denominator, and then that is simplified. All right, we have time to move on to another solving equation. So let's look at 24 right here. I'm going to erase the left side of 25. Okay. I'm highlighting the subtraction. Just like in 25 when I highlighted this addition sign, you have to be very, very careful with those. Anything that you multiply both sides of the equation by, you have to distribute that multiplication over both of those items, x and the 2 over x minus 3. Now, do you see that they went tricky on you with that denominator? You have an x minus 3 denominator and a 3 minus x denominator. Do you remember how to deal with that? If I multiply, if I multiply the numerator and the denominator by the exact same thing, -1, I can reverse the subtraction order, which is going to be very, very convenient in this case. So I'm going to rewrite the left side of the equation. And on the right side, the x minus 1 is now a 1 minus x. The 3 minus x is now an x minus 3. And now I see that these are identical denominators. I don't have to multiply by both x minus 3 and 3 minus x. I can save myself that grief. So I've got two sides of an equation, and I need to multiply both sides by x minus 3. I have to distribute the multiplication over that subtraction. And I'm going to write it slowly. I have an x minus 3 times x. I have a 2 times x minus 3 over x minus 3. And on the other side, you can just see right away the cancellation. And then as I look over to the center, I see that this also creates a cancellation. Now I'm going to rewrite what I have here. Actually, let's do this. Let's get this expanded because at this point it's turning into a polynomial. And when I'm solving the polynomial, I want to expand it, get like terms brought together, and then move forward. So x times x minus x times 3. Then I have minus 2, and on the other side, 1 minus x. When I get to the point of having a polynomial, I want to bring my like terms together, make one side set equal to 0. So I'm going to add x to both sides of the equation. And I'm going to subtract 1 from both sides of the equation. And now I'm ready to factor. I'm adding x. Oh yeah, the hard part about this stuff is it is really easy to make a mistake along the way. In fact, the hardest thing to do is to not make a mistake along the way. And so you want to approach these very slowly and methodically and think about each and every step you're doing. And every time you take a step, double check that the things that you just did are correct. Now, this factors to x minus 3 and x plus 1. Setting each of those factors equal to 0 gives me my solutions. But I have to double check. Do either of them make an original denominator equal 0? Oh, yes. 3 is out of there. Throwback to comedy sports when we used to have it. Okay, no reaction. You guys have all seen a comedy sports game before, right? Someday it will happen again. And what's great is for the rest of your life, An entire joke can be said just by saying 2020. That's it. You know that too. It's ridiculous. Anyway, -1 does not make a denominator 0. Yay! Now, we still have 10 minutes left in class. So what I'm going to do is I'm going to talk over the graphing stuff. Now I'm going to expect you to graph problems like 1 and 2. These are problems where you have a horizontal asymptote of 0. So when you create a sine line, you know whether you're crossing that horizontal asymptote or not. For this level of math, you're really just going through graphing these for the first time. If you continue to the next level, you'll go through this again. And you'll get to a point where you're stronger and better at working with some of the more complicated ones. I'm not going to ask you to graph anything like 3 and 4, but I am going to ask you to look at them and determine vertical asymptotes, horizontal asymptotes. Maybe I'll ask for x-intercepts, y-intercepts. So I will have some functions that I'm not asking you to graph, but I want you to determine certain aspects of what they would graph. So, what causes a vertical asymptote? Mm-hmm. Okay. You too. So, do you remember how to find the vertical asymptotes? You're solving an equation for what makes the denominator equal to 0. How do you find the horizontal asymptotes? You first check to see if the degrees match. Highest exponent on numerator and denominator are both 2. That means that it is just those leading coefficients, 5/3, for the horizontal asymptote. If they are not the same degree, so for this one, I have a degree 2 polynomial in the numerator and a degree 1 in the denominator. If they don't match up, I either don't have a horizontal asymptote or I have a horizontal asymptote of 0. And if you think about what happens to both of these polynomials when x gets humongous, that parabola is going to graph much steeper than your line. And it's going to get to infinity a lot faster. Can you see that that's creating a fraction that's basically top heavy, where it's just growing without bound into infinity? And so there is no horizontal asymptote. If this were flipped around the other way, then the horizontal asymptote would be 0. This is another set of problems where I expect you to not necessarily graph them, but be able to determine x-intercepts, y-intercepts, asymptotes. Oh wait, I am having you graph these. Ha! Liar. That's me. So, how do you find x-intercepts? Look at what makes the numerator equal to 0. How do you find y-intercepts? Plug 0 into every x. And oh dear, what happens with this? If you have 0 in the denominator, when you try to plug a number into the function, it is undefined at that point. And if you're trying to find a y-intercept, that means you don't have a y-intercept. Vertical asymptotes are numbers that make the denominator equal to 0, but do not make the numerator equal to 0. But I'm not going to throw at you those problems during this test where you have to worry about that situation. When you go to make the sign line, remember that you're looking at anything that makes the numerator equal to 0, which are your x-intercepts, and anything that makes the denominator equal to 0, which are your vertical asymptotes. So for this problem, positive 3 is an x-intercept. 0 and 5 make the denominator 0 for vertical asymptotes. And you can check any x coordinate, any x larger than 6, see if it creates a positive or a negative when you plug it into the function. And you can do one test number at a time. And this will tell you where the graph is above the x-axis and below the x-axis. It can help sometimes to shade what that means. So for example, if I plug a number greater than 5 in, I'm getting positive. That tells me that when x is greater than 5, I only get to exist above the x-axis. And when asymptotes are involved, that narrows down our possibilities. The problems I want you to sketch are problems where you do have horizontal asymptotes. So this one has a horizontal asymptote, and it happens to be 0. And that tells you, just by knowing that it's positive in that section, you know that it has to come down to that horizontal asymptote from above. X equals 5 is a place where the denominator is 0. It's one of the vertical asymptotes. Just by knowing that that section is positive, that means on the right side of asymptote x equals 5, you have to be heading up. And that gives you an entire section of the graph just by understanding how asymptotes must be followed and determining the sign of the function in each of these separate intervals. And my time is just about up with you. I know as soon as it hits 150, I'll all of a sudden have people just leaving. So I will stop. Oh, there it goes. No, don't leave. Everybody's leaving.